All right, everyone. Our homework last night was page 218. We're going to go over all three of these questions. This related to gravitational fields. We'll spend just a couple of minutes reviewing those fields along with the equations that we used yesterday to solve problems like this, and then we'll take a look at all three of these questions, right? Basically, we said a gravitational field is a line of influence that surrounds an object with mass. So the gravitational field surrounding the Earth, or any other object with mass for that matter, would look something like this. A bunch of field lines pointing toward the Earth, because things fall toward the Earth, right? You put an object in that field, it's going to fall toward the Earth. That's why the field lines point toward the Earth. Now, the Earth is a producer. The Earth is what causes the field in this case. Sometimes you may have something to experience the field. Maybe you got a basketball out here experiencing the field. Maybe you don't. Okay, whatever. Bottom line is you've always got a producer, and then sometimes you've got something to experience that field as well. If you've got information about what caused the field, in other words, information about the Earth, then we're going to use what we call the producer equation to solve for the field strength. Gm over r squared. M would be the mass of the producer. R would be the distance from the producer to wherever it is that we're trying to find the field strength. If you have information about this red experiencer, if there is even a red experiencer there, okay, let's say there's not. There's no experiencer there, there's just a producer. You don't have much of a choice. You got to use the producer equation. But if there's an experiencer there, and you know something about that experiencer, then you have the option of using the experiencer equation. G is equal to F, the force of gravity experienced by that object, or the weight of the object, divided by the mass of that experiencer. So if you know more about the thing that causes the field, which is the blue object here, then use the blue equation. If you know more about whatever experiences the field, which is the red object here, then use the red equation. What do you do if you know everything about both? Derek, up here, please. Okay, let's answer my question first here, guys, and then we'll go to yours, Stephanie. What do you do if you have information about both the producer and the experiencer, Stephanie? Use whichever one you want. I'd probably, honestly, if I knew enough about both of them to use whichever I wanted, I'd probably go with this one because it's a little bit easier of an equation. Doesn't really matter, though. Honestly, though, most times that's not going to happen. Most times you're going to know something about the producer or the experiencer, not both of them. Now, one final little thing, and then Haley, I'll answer your question, okay? There is a question on your test next Monday that gives you information about both the producer and the experiencer. Not all the information, but some of the information. You're given the mass of the producer and the mass of the experiencer. And you're asked to find the field strength. Now, I'm not going to tell you which equation you're going to use. It depends upon what you have more information for, the producer or the experiencer. But don't do this. Okay, and here's what every year that I give that question, I get a lot of people doing. People see two masses. Okay, they say, oh, look, I got the value of M1, the Earth. I got the value of M2, the thing that's experiencing the field here. Well, let's do this then. Let's say F is equal to Gm1 M2 over r squared. Let's find the force of gravity. Okay, that's not the question. If I ask you to find the field strength, it doesn't matter if I give you both masses. You're not going to use both masses. If I ask you to find the field strength, you're going to use one of those equations with one of the masses to find the field strength. You pick the mass that you have more information about. If it's the producer, great, use the blue one. If it's the experiencer, great, use the red one. But don't use the green one unless you're asked for force. Then you can use the green one, right? If you're asked for field, use the green one, sorry, the red one or the blue one, all right? Haley, what was your question? And then Stephanie, I'll get your question after that. Yep. Good question. Okay, when you're using that second equation, is there a way that you're going to have to find F, or are you going to be given the value of F? Generally, you're going to be given the value of F, but they may not call it F, the force of gravity. They may say it weighs 700 newtons. It weighs 500 newtons, whatever. That's a force of gravity, right? Weight is a force of gravity. So if they tell you how much it weighs, they're giving you the value of F. Usually you're not going to have to find F. So, if you did, You could find it this way and then just plug it into here. But if you did that, honestly, if you're going to do that, you might as well just use the blue equation from the start, because that's all that ends up being is, okay, when you plug that into there, that ends up basically giving you this equation. So in all likelihood, if you're going to use this equation, you're going to be given the value of F. They just might not call it a force. They might call it a weight. Stephanie? In this one? You can. Yeah, you can. You can take this green one and put it into this one, because that's a force of gravity. This is a force of gravity, right? But if you do that, watch what happens if I do that. Now, the mathematics gets a little bit ugly here, but it tidies up pretty neatly here. G m1 m2 over r squared over m. Well, this mass we're going to call m1, the mass of the experiencer. m1 cancels. What am I left with? G m over r squared. So basically we're saying becomes the blue equation, right? So, I mean, usually you're not going to bother solving for F and then plugging it into there. Okay, if you want to use the blue equation, you're probably going to go straight to the blue equation, right? I'm sorry? Well, okay, if you're asking for the force of gravity, generally you're going to use the green one. But you could, given the field strength, use the red one as well, because that gives you force as well, right? So if you know what little g is and you know what m is, go ahead and use the red one. It's easier than using this one, right? Just depends on your givens. They're both gravitational force, and they're the same force. So whatever seems to fit your givens better, use the red one over the green one. Okay? Our Christmas equations right here. Our red one and our green one. All right? All right, so let's take a look at these problems now. 1, 2, and 3 here on page 218. Number 1 says a satellite orbits Earth at a distance of 3 times the radius of the Earth above the Earth's surface. Here's the Earth. Okay, here's the radius of the Earth, and then the satellite is 3 times the radius of the Earth above the surface. So basically what we're saying here is the value of r that we want to use here is 4 times the radius of the Earth, which is 4 times, I believe it's 6.38 times 10 to the 6. Is that right? Is that the right number for the radius of the Earth? Okay. Multiply that by 4. What do we end up getting there? 2.552 times 10 to the 7 meters. Okay, that's R. What else we got here? Well, you know what? We've already solved for A, right? How many of the Earth's radius is a satellite from the center of the Earth? It's 4, right? 4 times the radius of the Earth. What's the magnitude of the acceleration of the satellite? This is the gravitational field strength, right? What do you know more about? The producer here, the Earth, or the experiencer here, the satellite? What do you know more about? The producer. So let's use the producer equation. Gm over r squared, 6.67 times 10 to the minus 11 times the mass of the Earth. That's not in front of us right now, but we have that on our data sheet. We have that on that table if we need it. I think it was 5.97 times 10 to the 24. Divided by r squared, which is 2.552 times 10 to the 7 squared. Okay, let's do this on our calculator to make sure you can do this correctly. Let's say 6.67 times 10 to the minus 11 times it by 5.97 times 10 to the 24. Let's divide that by, let's use some brackets here. 2.552. Louis, what's wrong there? No, I think it's 5.97. Pretty sure it's 5.97. Check that table again. Check your data sheet. I'm pretty sure it's 5.97. Where does it say 5.96, Louis? It's times 10 to the 7. Yeah, Louis, I think you just wrote that down wrong. Let's square that. Do the math there. 0.6114. Is that the right answer, guys? And that would be, we could say meters per second squared. The other units that we started using here yesterday for that are newtons per kilogram, 0.611. Look, this is a long distance up. Like this satellite is way, way up there. There's still gravity though. It's 0.6, right? That's still about, what, about, I don't know, 7% or so of the Earth's gravitational field on the surface. So it's still a significant amount of gravity, but clearly it's a lot less than what it is on the surface of the Earth. 9.81 on the surface of the Earth, right? Okay, number 2. 2 says an 80-kilogram astronaut is in orbit this far from the Earth's center. We want to find the gravitational field strength at that location. So we're going to say R is 3.20 times 10 to the 7 meters. Why did I do that? 10 to the 7 meters. I don't want to be in kilometers. I never want to use kilometers unless I'm dealing with V equals D over T. Always be in those base units. That's all we got. Oh no, we have the mass of the astronaut. We'll call that MA. No, you know what? We'll call it ME, because the astronaut's the experiencer, right? We have the mass. Oh no, we don't want to do that, because we're going to think that's the Earth, right? Now, you know what? That's fine. We'll just call the mass of the Earth the mass of the producer, which is 5.97 times 10 to the 24 kilograms. And we want to find the field strength there. Yep, Haley? Yep. 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 Sometimes, I mean, Haley, if you don't like that, if that confuses you a little bit, I'll just put just put a 3 onto the exponent there. Just do this, and this might seem silly. But that avoids confusion over what the exponent should be, right? Just punch it into your calculator, just like that. All right. Oh, this is a good question. This is kind of like that question on your test on Monday. What's the temptation when you see this data? It's exactly what I suggested the temptation on your test might be. G m1 m2 over r squared. That's not what we're trying to find. Don't do this. We're not trying to find force. We're trying to find field. Now, what do you know more about, the producer or the experiencer? Bruce? The producer, right? We know the mass of the experiencer, but we don't know the force felt by the experiencer. So let's use the producer equation. G is 6.67 times 10 to the minus 11 times the mass of the producer, 5.97 times 10 to the 24, divided by 3.20 times 10 to the 7 squared. And when you do the math on that one, you should get 3.89 times 10 to the minus 1. Now, there is another option here. Okay, Stephanie kind of alluded to this in a question earlier on. You could calculate the force using G m1 m2 over r squared. Okay, get the force of gravity between the two objects, and then turn around and say that G is equal to F over m using the experiencer equation. Guess what you get if you do that? But do you remember what we said when we were talking about that? Okay, you can solve for the force and then use the experiencer equation, but if you're going to do that, you might as well just go with the producer equation right off the top, right? That's right, though. Just a little bit longer, that's all. What was question B? What would be the magnitude of the field if the astronaut is orbiting the moon with the same separation distance? We won't bother going through question B because it's the same question, right? Except that the mass of the producer is different. So use the same equation. Just sub in the mass of the moon here where the mass of the Earth was, solve for. We should get a number that's smaller, right? Because the moon produces a smaller gravitational field. Okay, and sure enough, 4.79 times 10 to the negative 3 newtons per coulomb it works out to be. And finally, question number 3. The highest satellites orbit Earth at a distance of 6.6 times the radius of the Earth. What's the force? Okay, careful here. What's the force on an astronaut at this location? What's the force on the astronaut at this location? What do you want to do here? You want to use F is equal to m times g? Is that valid? Sure it is. If you know what g is, you could solve for g using this equation. Okay, use the mass of the producer, use the radius, okay, solve for g in newtons per kilogram, plug it back into here, and solve for the mass of the experiencer, right? Solve for the force there, and guess what? It works out to be 16 newtons. That's fine. It's not the way I do it, but it's fine. And get the field strength produced by the Earth. That will be the field strength experienced by the satellite. Multiply that by the mass of the satellite, get the force. The alternative? Why don't we just say F is equal to G m1 m2 over r squared? This isn't really a field question, is it? They're asking for the force. So just use the force equation, G m1 m2 over r squared. We got all the data there. Okay, plug in the numbers and solve. 70 kilograms, 5.97 times 10 to the minus 24, 10 to the positive 24, and then 6.6 times whatever the radius of the Earth is, square it, get 16 newtons. How many people did it this way? How many people did it the other way where they solved for the field caused by the producer and then said F is equal to m times g? Great. Doesn't matter. They both work. This is just a little bit quicker, that's all. Any questions on that? All right. If you haven't already done these 3 questions on page 220, then please do those for homework tonight. All right?